So, those of you watching this in the future,
Welcome.
back in the year 2020, we had this question, which is, what is the difference between a definite and indefinite integral, and which do you like better? Another way of saying it might be, which do you hate the least? So what do you think? What's the difference between the two, first off?
Well, a definite integral would have like a conclusion. So it would be, you would probably stop it at the x-axis. It wouldn't go into negative territory. It would end. An indefinite integral would probably continue on into each direction, and there would be no way of telling it. And it would basically be like theoretical calculus, which is dumb. And yeah.
Wow. I think you've got some things going on in your heart and soul right there.
Theoretical calculus is dumb.
So anyway, can someone say the same thing but in like a lot shorter?
I don't know. One is infinite, one is conclusive.
That's a way to put it. I would just say indefinite integrals, you don't end up with numbers. Definite integrals, you will end up with a number. So it's the same thing. Yours just sounded more scientific.
But honestly, there's no way to hate either one less. Sometimes it's easy to not have a number, and sometimes you can mess up a number.
Calm down.
Yeah. Which ones do you guys like best? How many people prefer indefinite integrals?
I don't know.
Oh, definitely.
How many people prefer definite integrals?
I don't prefer
I'm
anything.
integral-phobic, so
It's kind of a horse apiece here. If it's an easy integral, I like definite integrals because it's nice to know you've got a solid answer, but overall, indefinite integrals are much easier to solve because you don't got to throw all those numbers in at the end. So, depends on your perspective, I guess.
well, what if you're integral-phobic?
A lot of people are. You just have to get the vaccine.
Which is
This class. So, thank you.
has it been tested and has there been any like data
Oh
on
yeah.
how it works?
Everybody that's gone through this class has had the calculus vaccine, and they are all still alive and healthy.
Really?
I think.
Are they mentally stable?
Try it on me.
No, that's the one drawback.
One
May include insanity
What
for the
if
side
you
effects.
already are insane? Does it make it worse, or does it just keep it stable?
All right. I was going to go through and have you guys each individually whiteboard worksheet 6. Then I'm like, this is the first real integral homework, so I suppose I should record the darn thing so that people can look back and watch if you have questions. So, which ones would you like to talk about on worksheet number 6? What gave you the most trouble?
5 and 6. Or
5 and 7.
5 and 7, okay.
I think 7. I played 5. I think I did decent on that.
Yeah, 7's kind of tricky. The thing with 5 is you got to make it look nicer before you start it up. So number 5, we've got the integral from 1 to 2. And it's 3 over t to the 4th. And this looks uber complicated.
Uber everywhere.
So if we want to make it less complicated, we got to do a few things. What's something we can do to make this integral look a little bit easier?
3 times 12 over t fourth.
Yeah, so 3 times 1 over t to the 4th. So anytime you have a constant and it's multiplied by your the thing you're taking the integral with, you can take that constant and you can chuck it out in front of the integral. So I can just change this to 3 times the integral from 1 to 2 of 1 over t to the 4th dt. Can I do anything else to make it look nicer?
Yes.
What can I do?
T to the negative 4.
You got it. So I'm going to leave the 3 out there. 1 to 2, t to the negative 4 dt. And then it's just a matter of solving this. So again, the way that you start is by taking your exponent. You want to add 1 to that exponent. And so this is going to become negative 3, because when you add, you get lower if you're in the negative. So we'll have
Negative 4
t t to the negative 3, and then we put the inverse of that out in front. So that's going to be negative 1/3. Of course, that's multiplied by 3. Ugh. So 3 times negative 1/3 is negative 1, which is,
Negative t.
yep, negative t to the negative 3. That was fun to say. And then we got to do the, if this is our answer, we are evaluating that from 1 to 2. So that's equal to negative 2 to the negative 3 minus negative 1 to the negative 3.
I see.
I got
And
12.5.
12.5.
I did everything completely wrong
I got 0.875.
now.
Anybody else end with that?
Round to the nearest 0.875 is right.
I got
Yes.
That was the second time we did it, then I erased everything and did it a third time, got a different number, stuck to that number, so now you have a choice.
Oh, you
Kinda lost me there.
Yeah. The main thing is because we got two negatives, this turns into a positive and all that. So 0.875 is what your answer should be for that. The key point is this right here. That's what I really want you to take away from this problem. Everything after it is just keeping your numbers and your positives and negatives straight. All right, number 7. So there's our integral. And we need to do some things to make this look nicer. What's one thing we could do? Because we can't really solve it the way it is right here.
Well, 1/2
Natural
times
log.
1/x.
Yeah, 1/2. So we're going to pull out the 1/2. Integrated from 1 to 9. 1 over x dx. And does this look familiar?
That's ln x.
Yeah. So if we take the derivative of the natural log of x, we get 1 over x. If we take the integral of 1 over x, we get natural log of x. And that's written, something that you had to write down in your notes yesterday. So we've got 1/2 times the result of this. So it's going to be natural log of x evaluated from 1 to 9. And it's up to you how you want to deal with this 1/2. You could leave it out, multiply the entire thing by 1/2 at the end, or you could put the 1/2 out in front right here, and then do natural log 1/2 times natural log of 9 minus 1/2 times natural log of 1, and you'll get the same answer. So another personal preference deal. And out of this madness, you should get an answer of 1.1. Further questions on number 7? All right, anything else on the worksheet we should talk about? Let's do one more. Pick a good one.
Change number 1.
Number 1. Let's not do number 1. Let's do a different one.
3. I was like 3.
Sure, we can do 3.
The longest one. Okay, there's the second one.
3 gives a couple more steps. Does it? I have one less step. Figure out. I mean, like, I really did like 2 sets with each of these apart from the house. So I did a circle. I really did.
change colors. What color does number 3 feel like?
What colors do you have?
Black, green, red, and blue.
Feels great.
Green.
See, see,
I don't know if it was say green.
I definitely say purple.
I was
Well,
gonna
that's
say,
not an
I was gonna say purple or
Actually,
orange, but
I say burgundy.
it
then
is
it
an
went too
option.
Are we getting AP projectors?
It's kind of up to you guys. They're a little bit expensive because we only have, a couple people in the class here.
Okay.
But I can get a price for
I got
you.
a solution.
Ben, what happens to your inflation?
ask Ben to make the shirt.
Oh, that's right. You know somebody, right?
Yeah, it's my brother's wife.
Yeah. See how many people would probably get one? Raise your hand.
Depending on the shirt.
1, 2, 3, 4,
quality.
5, 6, 7,
I could get
8,
it as nice as
9.
mine plus.
So between 7 and 9 probably, if you could get a price on those. Okay.
What kind of material do you want?
Any material you want.
Fuji.
RN.
So for this problem,
It's not a material.
we got to do the integral
Whatever Fuji
and
uses.
we treat each of these separately. So when I take the integral of x to the 3, I add 1 to the 3, bring the inverse down in front, so that becomes x to the 4th with the 1/4 out in front. And then from that we're subtracting the integral of this. And so x to the 1, and then you add 1 to the exponent, so it'll be x squared, bring the inverse down, so that'll be 1/2 times 6x squared. And 1/2 times 6 is 3, I think.
Sometimes.
And that would be your indefinite integral. Then you just have to solve it from 0 to 3. So it's just a matter of plugging those numbers in.
So y is plus 1.
Hmm?
Y is plus 1 on the exponent.
That's just how integrals work. You always got to add 1 to the exponent and then bring the inverse down in front.
I thought we minus 1 and bring that down.
Nope,
That's
that's derivatives.
What?
See, it's all just silly.
Yeah.
Wait,
I'm just not awake.
That's okay.
Don't, that was me last hour. I had speed. We were just taking notes the entire time. No.
I have no idea what I'm
It
talking about.
was August 7th.
did you like how I just
We
did
actually
60
worked
votes?
the 20th,
You did?
except for the 1 week where I was on vacation.
See, I didn't know that you worked out. I didn't do after.
160.
Negative 6.75 is the
Well, add
answer.
extra dates
Uh-huh.
and then put the extra time.
All right.
Yay!
So that's the worksheet.
So funny.
I'll come around and get that from you. Have it out for me, please.
Well, so Mr. Hathaway, do you know when the homecoming pep rally is?
October 2nd.
First.
Thursday,
Is it?
I thought it was the day of the game.
October 1st.
Why is it the day before?
Well,
the game?
well, that's coronation. That is the pep
No.
rally, isn't it?
No,
No, it's
coordination
gotta
is
be
the
the second.
30th because the first is a no because of volleyball games.
But that means
Oh,
that's
so they're changing it?
on the 30th.
Oh, is it up there as something different?
Yeah, I mean,
I
it's,
think because of COVID, how the schedules changed after, like volleyball schedules. So coordination is the 30th because that's class games.
oh, okay, so they
Pep
Maybe
changed
we
rally
can get Mr. Nickel the 18th.
I thought it was the day
We
of
get
the
Mr.
game.
Hathaway
Oh,
the 18th
yeah, it's
in
Friday.
sports mesh
The
shirt.
Okay.
second is pep rally.
Thank you. Thank you.
So yeah, this was right, and then there's just the extra.
Time after.
Thank you.
I thought I was right. It wasn't. I still have to get the last donations on and then I back you.
20. Huh. I don't know.
All right. The next thing that we are going to have homework on is going to arrive tomorrow. And it's a special way to do difficult integrals. We are not going to get into that today. But when we do that tomorrow, the homework for that is going to be the virtual day stuff that you guys are supposed to do on Monday. So, hopefully, you can get a vast majority of it done in class after the notes, and all you got to do is take a picture of it, submit it on Schoology for that assignment that day, and you're good to go for your virtual stuff on Monday.
Are you gonna go to senior retreat?
I'm not going to be at senior retreat. They have other chaperones for that, and I gotta help take care of my little guy. So,
I'm a chaperone for senior retreat.
are you really?
No,
But it's not gonna be a little good.
would be a good idea.
Mm-hmm.
I agree.
Yeah, he's growing. That's for sure.
Yeah.
But
You got a
if it's
beard.
something you want,
Yeah.
Rules to being grown. Step 1, have a beard.
but if you're a girl,
Step 2, shave your beard.
Oh, I thought you said have a beer.
That's step 3.
Yeah.
Step 3.
We don't do that until his 3rd birthday.
you still
No,
recording?
wait.
Yes, I am.
There's a stereotype where, instead of milk, they,
Have fun,
nurse
edit
baby.
that out.
This is the drug and alcohol free zone.
Golly, didn't I ask if people?
Well, I don't have him drink it here. That makes it okay.
If you do, please let me know.
Okay.
You're lying.
Okay, so I wrote it, but it was unnecessary, and now I feel bad, so I'm just gonna get a whole new sheet and just write a number.
You're wasting paper.
All right. So, as for today, I just kind of want to make sure that we're all okay with how integrals work before we get into that brand new method tomorrow. So this is going to be kind of review, but I'd still like you to do it for me. Have out a sheet of paper. If you don't have paper, you're out of luck.
I have
But
extra.
I do have extra if you need
You
it.
don't have paper, what are you doing with
Not having paper.
Getting paper from Sarah.
your life? Yeah, that's always the way.
I need to work on my handwriting.
Have any of you ever worn 90% cotton, 10% spandex shirts?
Yeah.
They're amazing. Or complete polyester.
Polyester is a nice material.
Yeah.
It doesn't shrink.
Very.
All right, go ahead and solve this.
I have 0 fashion sense, but I understand material.
All of the knowledge that I left.
What?
You know, I don't know if I can solve that, but I could write the quadratic formula.
It's nice to know you're there when I need you, Jake.
What use would that be?
Well,
It's the quadratic formula.
Sometimes you just gotta remember that. Maybe plus my square is 4 AC over 2A. Like, you know.
I remember telling you.
You guys remember Miss Radcliffe's quadratic formula song?
I did not.
It's row, row, row your boat.
I learned it.
It's not
I learned it was about
Is it,
wash
what
out.
is it too? It is row your boat.
Papa's Louisa.
Oh, Papa's Louisa. There's something that goes to row your boat.
I don't remember.
I don't remember.
My preschool teacher taught me the
Yeah.
quadratic formula, but didn't tell me how to use it.
It's not very nice.
She did to make us feel smarter.
Nice. Go back to the tag.
Finish up the next 30 seconds.
1, 2,
Potter, be quiet.
Me just writing the problem down now.
Me having the problem written down, just waiting to go over it.
Wait.
It's just
I
one.
don't like that.
It's
There's
1.5, isn't it?
Just one.
No, I don't like it.
You can do it.
But
Potter.
But
What's the
it's-
answer?
You can do it.
you
But
know
it's
what?
not. Did I do it wrong?
I don't know, did I?
Cause there's not, I don't know.
I must have done
tried.
it wrong.
I tried.
If that's the
okay.
answer, I did it way wrong.
I broke my wrist.
What'd you get?
I got 0.
You got 0.
I got 0.
I didn't get 0.
Need that accent color.
What's that?
1.5?
1.5 is what I got.
Yeah,
3 squared is 9. 9 times a half.
Katie.
Is
Oh,
Oh my goodness.
Not 8.
How
Yeah.
is 9 divided by? I
All right.
rooted it instead of divided it.
Katie.
Oh,
You and I can go.
Oh, I got it right. I just forgot to write it.
Check your wardrobe for anything orange.
All right. We're going to go through this together. Integral of
Take your
x.
keto wig back. Whatever.
This is x to the first. So we add 1 to the exponent. That means it's a 2.
It is.
And the inverse comes out in front.
Yay.
When you have a constant and you take the integral, you just add whatever the letter is that you're taking the integral with respect to. So that becomes an x. Because it's like if you took the derivative of x, it would just be 1. So this is evaluated from 0 to 3. So you plug the numbers in.
No, 4.5 minus 3. 1.5.
And when you plug 0 in for all those, you get 0. So when you do that, you should end up with 1.5, because this is 4.5. And 4.5 minus 3 is 1.5. Placido.
Does 1.5 have to have the 0 to 3 up? For proper notation?
For what? For this?
Yeah, like if you get 1.5 and then you have to put the straight line the 0 to the 3.
What's the question?
So for the answer, you have to have the 0 to 3 line in it.
I'm cold.
Like down here?
Congrats.
Yeah.
No. Once you put these numbers in, you can get rid of that.
Sweatshirt.
Yep.
But I'm like,
Good.
after this, I'm not going there.
Next question. The
It's only
integral
raining and cold. Well, that's expected.
from 0 to 1 of u times the square root of u
Okay, see, that's what
plus the cubed root of u.
You know, the funny part is I didn't even get the last one right.
Do you think you can solve this?
I don't know. Can you?
Which one are we solving?
So I already made the joke.
Solve for the integral.
Oh, I did not see that.
You find the derivative of it.
Haha, I put negative 1 half instead of 1 half. I'm so smart.
You're supposed to get some really weird exponents.
Yeah, the exponents are going to be a little funky.
You know, for one day I can bring it.
It's okay. You really technically don't even need a calculator.
Why are you attacking yourself?
Okay, never mind. I was trying to be nice, but never mind.
I see.
Good?
Whoa.
It's good?
That's one
Yeah.
and a half.
Make sure to get your answer in decimal form.
Well, I just
Rounded to 3 digits.
I'm fine with the calculator.
Size. Well, my calculator gives me fractions automatically. And so it's
Math,
really nice.
yes.
Okay, that's it. You got to do it in scientific notation now.
Okay. I will. Technically,
I would not, I refuse.
there's not really a good scientific notation of this.
12.
There should be.
There is.
Well, no, you're right. There's
No.
not really.
They are.
Because it would just be excess writing.
Mm-hmm. That's why it's a punishment.
Yeah, it's just times the negative first.
17 over 12, or 1.416, or 1.1417. It depends on where you, if you round or if you cut it off.
I have no idea if I did this right.
Wait, do you want us to round or do you want us to, what is that,
We're close to what I got.
truncate? truncate?
Yeah.
Do you care if we truncate or round?
What's truncate?
Just chop it.
No, don't
All
chop
of a
it,
sudden
round
it's
it.
showing
Okay,
Yeah.
hashtag best is ultra rich people.
Okay, so 1.417 or 1 and 400.
Two-thirds
No.
plus
Are you okay? I'm so used to saying actual decimal numbers instead of points. Like I'll say like 400ths or
Mhm.
so it's
What's
like.
the answer? Time this back.
Well, now you need.
I actually haven't heard the right answer yet. I've heard a couple answers, but
0.708.
no,
1.16.
no.
What did I do wrong?
What's it? No.
0.829.
0.829.
Hey!
Wait, what?
You got one wrong.
Let's do this one. Can we?
Simplify
Yeah,
the
we'll do
form,
this
take
one.
the integral of it.
Oh wait.
You shouldn't have to
Yeah,
simplify anything, no.
No.
It's a lot of calculating.
Yeah.
Wait, what?
I felt more confident on this one though.
I don't understand.
Okay. So, like most of these, we gotta make it look prettier before we start doing anything with it. So, in order to do that, let's multiply this u through first, but what's another way of writing square root of u?
Well, it's a scientific notation
Yeah.
of it.
So, u times u to the 1/2. And how do you write this one?
Oh,
U to the third.
I did times
Yep.
that. That's what I did.
Okay. Evaluated from 0 to 1. So far, so good.
Can't you pull the u out?
Well, that's not a constant. We can only pull constants out.
What was the answer?
So multiply u to the first times u to the 1/2.
0.829.
You got to add the exponents. So that's going to be u to the 3/2.
That's where I did wrong.
And u to the first times u to the 1/3. We got to add those. So 1/3 plus 4/3 is 5/3.
No, it is
Right?
1/3 plus 3/3.
Oh yeah, 1/3 and 3/3. So 4/3 is the answer. Good. And that's all evaluated from 0 to 1. So we plug those numbers in.
No, wait, that's.
Wait.
No, you didn't evaluate them yet. You
You
just
haven't done
distributed.
Oh,
Numbers
yeah, I didn't
yet.
even do the integral yet.
I was like, you'll get what I got to you now, and then it will be wrong.
Boy, I'm glad I recorded this one.
It's a rough day, it's okay.
Oh,
Okay.
Mr. Mason was having an off day today.
I would even make this.
He's off. He is off.
Like, really bad.
Y
off.
equals -1. You put y equals 1.
It was weird.
We forgot a negative.
All right.
You're hating on him.
So let's make
No,
sure that
that's
we
just- that's a lot.
do these integrals properly then. So if this is 3/2, that means we got to add 1 to this exponent, put the inverse out in front. So 3/2 plus 2/2 is 5/2, right?
Yeah.
Okay. So u to the 5/2, and we put the inverse of that out in front, so that's 2/5.
1/2 plus 2/5.
And then this guy here, we got to add 1 to the exponent. So 3/3 plus 4/3 is 7/3. So that's u to the 7/3. Inverse comes out in front, so that's 3/7. All right. Did I do that right?
Yeah.
Okay, good. So that's evaluated from 0 to 1.
Yeah, there's 4 plus 2 is 7.
So 2/5, 1 to the 5/2, plus 3/7, 1 to the 7/3. And when you plug all that into your calculator, you should get 0.829.
8.29
Or
times
8
10 to the
to
negative
85.
first.
Thank you.
You're welcome.
Say, bang.
Mr. Hathaway,
What?
got the right answer, but I don't know how I did it. I
Well-
got all the wrong numbers.
Whoa.
But I got 0.829,
So you cheated.
basically. I got the right answer the wrong way.
That's okay. And you know the fun thing is, and this we talked about this a little bit last year in regular physics, is there's oftentimes more ways than one to solve these problems. So if you get the right answer and it totally doesn't match up what I did, you're probably just fine.
You just got
We're
one.
incredibly lucky.
Incredibly lucky.
Got a star.
All right. I'm going to walk you through. Actually, no. Yes. I'm just going to walk you through this next
Never
one.
mind.
Because I want to make sure we don't lose what integrals really are here. So let's say we integrate something from -1 to 2, and we want to integrate x cubed dx. So if we solve this, we got to add 1 to the exponent, so that becomes 4. The inverse of that comes out in front, so it's 1/4 evaluated across that line there from 2 to -1, or -1 to 2. And you'd plug those numbers in. And that's going to give you some number. And that number ought to be 3.75. But that number isn't what I'm really concerned about right now. I'm curious as to what this actually means in terms of some sort of graph. So maybe you have a graph, and it looks like this one, because it's x cubed, the graph of x cubed looks a little bit like this.
It's like an inverse cosine.
I've been taking the top
Inverse
number minus the
tangent.
bottom number this entire time. I didn't know you're supposed to use both numbers.
-1. Yep.
What?
And we'll say this
See,
is
like it
2
says
right
2
here.
-1, I've been plugging in 3. Yeah.
So if I got this down to decimals, it would be 4 minus 0.25. So what this all means is, when I'm taking this integral, on the positive side I got 4. So if I took the area of this whole thing, it would be 4.
No?
If I took the area of this whole thing, it would be 0.25.
-0.
Right. So then when you're doing that subtraction, you're actually subtracting the areas of each of those things as you do the problem. So that's what this all means. Your overall total value of the area would be the big one minus the little one. It's not adding up all of it combined. It's this area minus that one. So when you're doing these definite integrals, that's essentially what you're doing if you think about it graphically. Questions on this? That's good for today then. Be ready for a brand new method of taking integrals tomorrow.
I think you can wait.
So,
We should do that
question about
Monday.
insurance.